First of all, thank you to all the speakers for their time and insights. Thank you all for participating. Paloma and the speakers have given you a glimpse of what we have achieved, what we have delivered in Reaxys to really enable acceleration of chemistry research. I am here to give you a glimpse of what's to come. Reaxys will continue its focus on the three pillars that we have identified for innovation, which is namely comprehensive data, application of smart technologies on that data, be it for search or be it for predictive technologies, and to deliver these in a user-centric design to make the experience the best. With regards to those three, we will continue our journey on making our content the most comprehensive and of the highest quality. Over the coming year, we will focus on improving the underlying search technology and relevancy ranking, and improving user experience with regards to patent family member clustering and bioactivity export. And in the space of predictive technologies, we are rebuilding the Reaxys API and also working on some new APIs. As you heard from Mark and Mandar, we continue to focus on enhancing the predictive retrosynthesis function further. The award-winning programmatic technology that we have developed, we are applying that technology now to journals, which enables us to go from covering 16,000 journals to 18,000 journals, making Reaxys the most comprehensive chemistry solution. This enables, the programmatic extraction enables really, really fast delivery of the content from these journals. This does not mean that, we'll stop manual excerption. Manual excerption is key, and we will continue to focus on the manual excerption. We are also extending the IPC classes. Let me see the slides. I don't see it moving. Still stuck on the, sorry. Give me a second. Okay, hopefully you can see the screen now, at least I can see it on my end. As I was mentioning, we are expanding the coverage of our journal content from 16,000 to 18,000. Further to this, we are expanding the substance extraction from new IPC classes to really cover rapidly evolving fields like clean energy, battery technologies for cars, organic materials for solid state devices. Importantly, in terms of target and bioactivity data, we are extending the manual excerption of these data to cover patents from China, Korea, Japan, and Taiwan. Earlier, we already covered the WO, US, and EP patents. So we are now going from 3 patent offices to 7 patent offices to give you the most comprehensive structure, target, activity data set. I must call out Nina and Michael in our team who are leading this effort. So if you have further suggestions, please definitely do reach out to them. With regards to improving, we can add all this content, but our focus is also to improve the discoverability of this content. And we are doing this, number one, by focusing on improving the underlying search algorithm and technology to make this content really discoverable very easily. Reprogramming the relevancy rankings so that the results that you get match your user, the intention of the users. The most relevant content is delivered to you first. And really importantly, to deliver a best-in-class author name search and filtering capability so that you're able to identify references attributed to a specific author. A couple of screenshots are shown below, and this will be coming in Reaxys soon. I must thank Jay, who's leading the effort on search technologies and author name search. So if you have further suggestions, please reach out to Jay. We are constantly gathering feedback, taking users' suggestion to improve the user experience further. Two of the things that are coming are grouping of patents by patent family member. As we have expanded our patent coverage, we realize from users that this is important. So this is going to be the focus, being led by Nina. Our structure activity visualization is really strong, and we are, Anindya and team are making it even more user-friendly so that the exported data can be easily ingested in commonly used tools for structure activity relationship analysis, such as Spotfire. So this, you have it, this will improve the user experience even further. In terms of predictive technologies, there's a lot happening. Marcus is leading the effort to rebuild Reaxys API to make it user-friendly and to make it meet the industry standards. It will be a RESTful API, and importantly, it will have really standard Swagger documentation so that from the moment you get access to API to the moment you can integrate it in your workflow, that time period really reduces and you can get on with maximizing the benefit of API in your workflows as quickly as possible. There are two new APIs being built by Marcus and team to really focus on supporting chem informaticians because as Mark mentioned, as Yuri mentioned, there's a lot of work which is being shifted towards in silico side of things. And here, chem informaticians typically need API access while chemists typically have .com or utilize the .com access. We're building two new APIs, the Reaxys retrosynthesis API and the synthetic accessibility API to support the generative design workflows. The users will be able to run batches of molecules of up to 1,000 molecules, and it'll come with standard documentation and Python SDK wrapper so that you can really integrate it in your existing tool sets, such as Live Design and Design Hub or other internally used or internally developed tool set. Not to forget, predictive retrosynthesis. I think there were a couple of interesting questions asked, especially around stereochemistry. So stereochemistry is going to be a focus of the future development with regards to retrosynthesis, predictive retrosynthesis. The stereochemistry is already supported in published retrosynthesis, but this will be focused for predictive retrosynthesis. Besides this, the underlying model is being updated by Mark and the team with the latest Reaxys reactions data. And we are also expanding the starting material library to go from 10 million to 80 million. And this is helpful because you'll have more molecules for which you can get a route. Last but not the least, Mark mentioned this, and this was a question asked around customization of models. So we are going to focus in 2024 on having the model retrained with Reaxys reactions and customers' own reactions. This is helpful, as Mark said, because customers' reactions typically have negative data, which really improves the performance of the model. Like many pharma companies or chemical companies, we have an open innovation model. We continuously innovate through really research partnership with cutting edge on cutting edge research with leading academics. The two research partnerships that I want to highlight are, number one is the partnership with Professor Schwaller at EPFL in Switzerland on chemistry relevant large language model. This is to focus on improving the recognition of chemical structure representations by LLMs, improving really the understanding of chemistry concepts and chemistry intuition by large language models, and to be able to utilize the Reaxys knowledge in these large language models to deliver the right insight to the end user. The second project that I really want to highlight is the work with Professor Lapkin at University of Cambridge, focusing on knowledge graphs for green synthesis and conditions prediction, where we want to utilize Reaxys data to have optimized synthesis route which meet various green heuristic needs, such as you may not want some halogenated solvents, etc., and to identify optimal conditions for giving the higher yield. So we support these research not by providing the very high quality data that we have, providing the chemistry expertise that is there in the team, and also by sponsoring PhD positions. So we are sponsoring 2 PhD positions, and we invite interested companies to become part of this industry academia research partnership. The efforts are being led by Christiane and Timur, and I would highly encourage anyone who's interested in participating in this industry academia partnership to reach out to them. I really want to re-emphasize that Reaxys, through all your feedback, through all the ideas that you have shared, and through the tremendous effort of the product, the technology, the engineering, the marketing, the sales team, it has really helped Reaxys become the most comprehensive, innovative, and user-friendly chemistry solution. And truly, Reaxys is for every chemist. On behalf of the whole Reaxys team, I would like to thank you for your time, and for really all the speakers for their time and the presentations, that insightful presentations that they gave, and for all of your suggestions, all of your ideas from the broader Reaxys family of users to make Reaxys the best chemistry information solution out there. So thank you, everyone, and have a lovely rest of the day.